The lesson outcome for this video is, I can factor completely. Now, we've now talked about 4 different types of factoring. We've talked about factoring out a GCF. We've talked about factoring a quadratic expression. That means there's an x squared term in it that has the leading coefficient equal to 1. We've talked about factoring a quadratic, again, an x squared situation when we know a is something other than 1, which is what we call magic number or magic term, if I could spell, sorry about that, or AC method. And then the 4th type of factoring we've talked about is the difference of squares or perfect squares. Now, factoring completely means that we are going to have problems where we'll need to factor out a GCF first and then follow that with one of our other 3 factoring methods. So it means that there might be 2 different factoring steps to complete. So if you look at the problems that are listed below, and I just added one, but if you look at these, not that. If you look at this, that should look familiar. That's an example of factoring out a GCF. Then there's this example here where a is 1. This example is an example of when a is something other than 1, which we would use magic number for, so number 3 here. And this last one down here is an example of a difference of squares. On the next 2 slides, I'm going to show you problems that look a lot like these 4, but that combine GCF with one of the other 3 methods. Let's take a look. Okay, so the directions for these 2 examples says factor completely. One thing that we need to be very careful of at this point now, moving forward, is that we should always look to see, first and foremost, is there a GCF in the problem that we're about to do? Okay? If there is, that has to be our first step. So although this might look like a difference of squares maybe at first glance, which it is not, but there's a subtraction sign in 2 terms, we first need to look for a GCF. Since 3 and 12 are both divisible by 3, that means they have a common factor of 3. This is an x squared term, but this doesn't have an x term. So what we can factor out of both terms is a 3. When I factor 3 out, 3 divided by 3 is 1. We can write the 1 or we don't have to. And we did not factor any x's out, so we still have x squared. Then when we factor a 3 out of the 12, or the negative 12 if you want to think of it as such, which you should, I suppose, negative 12 divided by 3 is negative 4. We didn't factor out the negative. So at this point in the parentheses, we have 1x squared minus 4 because we factored out this 3 out here. So here's the next step. In the past, when we had factored out a GCF, we were just done at that point. But now, we need to look at what is remaining in the parentheses to see if it is also factorable. In our parentheses here, we have 1x squared minus 4. There's 2 terms, there's subtraction in the middle, and indeed the 2 terms are perfect squares. This is a difference of squares. So that means we are going to put our 2 sets of parentheses down so that we can factor the difference of squares, and we are also going to bring our 3 right down with that answer. 1x squared means that we're going to have x times x to give us 1x squared. 4, the square root of 4 is 2, so we know we're going to put a 2 here and here, and then we put a plus in one and a minus in the other. This is now factored completely. Go ahead and try the second example here. Pause the video, try it out, and then check back to see how you did. All right, so you should have realized that 20 and 45 do have a common factor of 5. That is the greatest common factor. We're going to factor out a 5, and what we're left with is 4x squared minus 9. 20 divided by 5 is 4, and 45 divided by 5 is 9. What's left in the parentheses, 4x squared minus 9, is once again a difference of squares. Therefore, we're going to put our parentheses down and bring our 5 down as well. 4x squared is 2x times 2x, and 9 is 3 times 3, and we're going to put a plus and a minus in our parentheses. So we have a couple more examples here of factoring completely. The first one says 3x squared minus 3x minus 90. The first thing you might be thinking you need to do is multiply the 3, the a, times the c, negative 90, to get negative 270. But don't do that. Because the first thing you want to do, as I mentioned on the previous slide, is look for a GCF. It is very important. Okay, so in this first example, we have 3 and 3 and 90. What's the GCF, the greatest common factor, between 3, 3, and 90? Well, since 3 only has factors of 1 and 3, same thing here, there's only one option. Is 90 divisible by 3? And it is. So we're going to factor a 3 out of every term. Can we also factor out an x? No, we can't. And we can't because the 90, negative 90, does not have an x. So we're only going to factor out a 3. When we do that, we have 3 divided by 3 is 1, x squared, so just x squared is fine. Negative 3 divided by 3, we're going to end up having a negative 1x here. And you could have just written x, but I put a 1 in there, minus 1x. And then negative 90, if we factor out a 3, leaves us with negative 30. Again, what we need to do here after we factor out the GCF is look to see if what is left in the parentheses is factorable. Notice the leading coefficient in the parentheses. Now we're not paying attention to this now. The leading coefficient in the parentheses is 1. If a equals 1, all we need to do is take our c term, which is negative 30, and write it out here and find its factors. 1 times 30 is 30. But one of them needs to be negative. 2 times 15 is 30, but one of them needs to be negative. 3 times 10 is 30, but one of them needs to be negative. It is not divisible by 4. It is divisible by 5. 5 times 6 is 30, and one of them needs to be negative. Which of these factor pairs adds up to the middle term of negative 1? Well, it's this set of this pair here, except for the negative needs to be switched. This needs to be positive and this needs to be negative in order for it to add up to negative 1. So now we can leave our 3 right here, and then we're going to put 2 sets of parentheses down. We're going to put x here, and we're going to use our positive 5 and our negative 6 to go in the parentheses. This is now factored completely. Alright, and the last example for this video is 12x squared minus 38x plus 20. Again, you don't want to jump right in and start multiplying 12 times 20 and writing that as your magic number out here unless you first check to see if there's a GCF to factor out. 12, 38, and 20. What is their greatest common factor? It might help some of you to actually go through and jot down some of the factors. 1 times 12 is 12, and 2 times 6 is 12, and 3 times 4 is 12. If you look at those, starting with the largest, 12, well, we know 20 is not divisible by 12, so that is not our greatest common factor. How about 6? Well, 20 is not divisible by 6, so we can cross that one out as well. 20 is divisible by 4. Is 38? No, it is not. So 4 is not our greatest common factor. And again, 20 is not divisible by 3 either, so that's not our common factor. You may have guessed it from the beginning that 2 is the greatest common factor, but we want to make sure that we are getting the greatest number possible. Not just any common factor, the greatest. So it is going to be 2. So I'm going to write a 2 right here, and I'm going to write what's left in the parentheses. So 12 divided by 2 is 6, so we have 6x squared, minus 38 divided by 2 is 19x, and then 20 divided by 2 is 10, so plus 10. Now, what we're going to do, we're going to ignore our GCF out here. We're going to look just at the parentheses, and we'll notice that we need to factor this by using magic number. 6 times 10 is 60. So we're going to write 60x squared right here, and we need to find all of its factors. If you'd like to pause the video and check and see if you can find all the factors of 60 before I do it, go ahead. 1 times 60, we're going to need an x with both. 2 times 30, we need an x with both. 3 times 20. 4 times 15. 5 times 12. There are a lot of factors of 60. And 6 times 10. Now we need to look for which factor pair adds up to negative 19x. Again, here's 19x, right? 4 and 15, it adds up to 19. We're going to need both of those to be negative in order to get negative 19 for our b value. They still multiplied to give us positive 60x squared. All right, so what I'm going to suggest that you do here, and this is a little tricky, is we need to do our magic number steps right here. Okay, and there's going to be about 3 steps. And then we need to end up with our 2 in our final answer. So what I'm going to do is I'm going to bring this 2 right here, and we know that we're going to end up with 2 sets of factors in parentheses here, with 2 steps in between. So I leave some space for my work. So like usual for magic number, we're going to separate the 6x squared, the first term, and the last term, which is plus 10, and we're going to take and put this in the middle. Minus 4x minus 15x. Now we're going to put that vertical line down the middle right here, and we're going to factor the GCF out of each side. 6x squared and negative 4x have a common factor of 2x, and we have to say what's left. That'll be 3x minus 2. And go ahead and check that and see if you understand how I got that. Now on the right hand side, negative 15x plus 10, I'm going to definitely factor out the negative that leads this work right here. This negative has to be brought down. And then 15 and 10 are both divisible by 5. Negative 15 divided by negative 5 is 3. I still have my x there, I didn't factor it out. And 10 divided by negative 5 is negative 2. Do my parentheses match? Yes, they do. That's good news. We're going to go ahead and write 3x minus 2 then in our first set of parentheses. And then we're going to write what's left, which is the 2x and the negative 5 over here. And we have now factored this completely. We need to include that 2 out front.